Hey Living Good Earth Scientists, I'm going to go ahead and use this video to walk through lab number 1, particle size and erosion. Please, I really want you to try to do this lab. Get away from your computer, get away from digital learning, you do it. I'm showing you this video in case my written directions do not make sense, or in case you do not have the supplies, and absolutely you could sit and watch my video and use the data to complete your lab. So, first thing, will gravel, backyard soil, sand, or potting soil hold the most water? So I've gone outside and found some gravel, some sand, some potting soil, and my backyard soil is clay. And then the second question, will those soils erode the most? Now I do understand some of you may not have gravel, even small gravel to large gravel, so you could, improvise here. Use, if you have little beads inside your home, or marbles or ball bearings, things that could represent the gravel. Sand, there's probably nothing you have that could replace that if you do not have sand at your house. Potting soil, what you possibly could do is if you were to go out and maybe a flower bed or under leaves at your house, you may have a dark soil. You could use that and then use clay, which is a lot of what we have in Georgia. So it may not be potting soil, but it's two different types of soil. So find however many you can of these substances, and then we're going to do our hypothesis. I'm going to just read them. You can pause the video at any time to stop and write. Which material do you think will hold the most water and why? And then your second hypothesis, which of these materials do you think will erode the most and why? Our materials, you'll need the 4 soils. You're going to need a stopwatch. I'm just going to use my phone. You're going to need a measuring cup, 4 disposable cups with holes poked in it. And so it says plastic cup. Any cup that you can throw away. I'm going to actually put 15 holes. I'm just taking a safety pin. And I just poked 15 holes in all 4 of them. If you do 10 holes, just make sure all 4 of them have 10. I would recommend maybe 15 once I got my cups. I'm also going to need 4 cups. I would prefer these to be plastic because you're going to be able to see better, but if not, use what you can. And I went ahead and wrote potting soil, sand, clay, and gravel. I wrote that in Sharpie. You could also improvise and just write it on a sheet of paper and then set the cups on the paper if you didn't want to write in them. That's not a problem at all. And you're going to need water. So the first thing we're going to do is we're going to place one of the 4 cups with holes in it into the empty plastic cups. So now I have my whole cup in my empty plastic cup, and I've done that with all 4 of my cups. I'm going to measure and add 1 cup of sand into one of the plastic cups, and I'm going to do it with the one that says sand. And I actually pre-measured these. These are little Easter egg cups, and they actually hold 1 cup. And so I'm going to go ahead and pour that whole thing, and this is actually just a 1 cup, so it's going to come all the way to the rim. All right, so I have 1 cup. And then I'm going to repeat that for all my other cups of soil. So I'm going to go ahead and do my potting soil. And I'm making a mess, which is fine because I'm outside and I'm using a container that I can easily clean up when I'm done. I'll go ahead and do my soil. Again, I already measured these. You're going to want to make sure that you measure them because everything in science you want it to try to be exact. And this one, I'm going to break it up a little bit. All right. Okay, and then I'm going to do my gravel. All right, so I have completed steps 1, 2, and 3. I have 15 holes. I put 1 cup of potting soil, and it's sitting in a plastic cup that says potting soil, and I did that for all 4 of my soils. Now I'm going to measure a 1/2 cup of water. So I'm going to go ahead and do a 1/2 cup. And number 5, I'm going to get my stopwatch ready, and I'm going to pause for just a second. Okay, I'm going to move on to step 6. I'm going to pour a 1/2 cup of water into my sand sample, and I'm going to allow it to drain. I'm going to attempt to do several things. Hold this up. I'm going to use the timer on my clock. Actually, I'll probably pause it because y'all don't want to sit here for 30 seconds. So I'm going to pour and let it sit for 30 seconds, and then I will come back on. Okay, so I'm going to let that sit for 30 seconds. Well, I guess I can't pause it because I'm... Okay, so I went ahead and actually did the experiment with all of my gravels, or all my soils, and I have the results sitting in front of you, and I don't know how well you can see them. But what you have to do now is fill out your data table. And in the type of soil, you're going to list either sand, gravel, potting soil, or the yard soil, which was clay. So the most amount of water that drained into the cup, so that would end up being your gravel. You can see how much water we ended up getting from our gravel. The second greatest amount of water that drained into the cup was sand. And it was close between the potting soil and the clay, but it looked to me like potting soil had a little bit more water that drained than the actual clay did. So you'll want to record those results. And then number 1, what happened to the amount of water the soil held when you changed the type of soil or particle size? So if you paid attention, gravel was the largest particle, then sand, then potting soil, and then clay. Clay is very, very fine, and that's why it sticks together so much. So what happens when you have large particle size and water goes through it versus when you have small particle size and water goes through it? So you're going to want to write what happened and why you think that. And number 2, why would the particle size of soil affect how much water is held and then how much water can go through? So why does it, large pieces of particle, why does the water go faster through that than the small particle? And so describe why that water is moving faster and slower. And then in conclusion, based on your results, which type of soil will erode more? So if we had these soils out on our yard and it rained or the wind blew, which one do you think would erode more? And then why do you think that? And just do the best you can to answer it. And if your results are different from mine, that's okay. That's what science is. It's about having, and you ultimately would do this many, 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 many times to come up with your answer. But just based on our results, go ahead and write down your thoughts for erosion and particle size.